was just keeping the information without thinking about it.
Oh yeah.
Because if you start thinking,
it's very hard.
The minimum is thinking about. Well, I think we have to give at least the same credit to both opinions, at least, because if you start thinking, there is something strange in what they taught to you.
Let me just say something. Granitic rock, which is what our continents are made of, weighs 2.7 times what water weighs. That's how you look for the differences. Basalt, which is at the bottom of the ocean, weighs 3.3 times what water weighs. So you got 2.7, 3.3. Obviously, basalt is much heavier than granitic rock, even though when we have granite, we go, oh, it's heavy. It's really light compared to basalt. Basalt is heavy. So we have the process in our science classes called differentiation. Differentiation means, let's say you have oil and water and you stir them up.
Yes,
and
yeah, I understand.
Okay, so the lighter stuff goes to the top. Okay, and especially now, lighter stuff doesn't go to the top if it isn't cooked, if it isn't melted. If it's solid, it's not going to go to the top. It's just going to be all mixed together. So you have all this mixture of stuff together, but if you heat it right under the crust, you know, for some miles down, then the lighter stuff is going to go up. Because you're going to melt it, and the lighter stuff goes to the top, heavier stuff sinks to the bottom. Well, what's happened is that the lighter stuff came to the top, and of course we had a crust, which was cold, you know, whatever it was made of, a bunch of crystals and shit. So this stuff comes up through these like vents, and as it gets to the top, it cools and hardens. So you get rocks, pillow rocks of granite. But because it was liquid when it came up, heated rock, liquid, it tends to be like water, opportunistic. That is, it goes to way, it goes fills in the spaces.
Yes.
So
it
fills in whatever, you know, pour water, and it fills whatever is low. Okay. So melted granitic rock is going to fill the empty spaces. So if you have this ball, and this granitic rock is melted, then it will fill whatever empty spaces there are. So it will make a smooth ball. Well, if you have a smooth ball, how could we have this? This has got two layers. One has heavy stuff at the bottom, and one has light stuff at the top. The only way that could happen, not because I'm saying so, it's because physics says this. And it's one of the things about geologists, they don't study physics. They'll tell you that they studied physics, but they don't really. So geologists say, well, this is true, you know, we've had oceans for billions of years. No, it really didn't, see, because all this granitic rock was differentiated to the surface, and it made this smooth ball. So the earth is smooth. The only way it would not be smooth is if it was growing. Then the crust would crack apart. So as this granitic rock was coming up, the crust would crack apart. Even the sedimentary layers, that are all the crap that sits on top, that would crack apart because it's spreading. So you have what are called ridges and flatlands. They're everywhere on Earth. You have ridges, they go like this, and they go back up again. If you took those pieces and pushed them together, they'd join together. All over the American Midwest. At the edges of rivers going out into oceans, they cracked apart like this. They have two edges, and then it actually goes down quite a ways before it. But those were together. The reason that they're cracked on the edge of a continent is because a continent has to go like this, and so it spreads on the edges, and then it builds mountains in the middle or near the edge. So you get mountains, and the water comes up and covers it up, and you get that. Well, of course, that's natural physics. That's how things have to work. So, but the only concomitant that's missing is the growth part. That
yes.
For all these processes to take place for there to be ridges and flatlands and there to be cracks on the side. The only way that could happen is if the Earth grew. It's just no other way. Otherwise, it'd just be a smooth ball. Why would it be anything else but a smooth ball? It's like saying, well, the Earth, it's a smooth ball, right? No, it isn't. It's got these pieces, and then it's got this basalt underneath it, and it's got cracks, and it keeps on spreading and getting wider. So why don't you just take the cracks and move them back together? Well, you can't do that because then you'd have to have a smaller Earth. If the cracks are spreading and you would move them back together, then all that stuff would just go back down until the two edges came together. That would let's just say you have a ridge and you have flatlands and you have another ridge and there's a crack up in the middle, presumably there was. So you just make everything go down and would bring the two ridges together and they come together. Now the interesting part would be if they fit together.
Yes.
Well, wouldn't that be interesting? If I had a vase, if I had 10 shards of a vase, and on the edges of the vase they had like strings sticking out, and I'd see the strings and they would go to the other shards of the vase, which would make the problem much simpler than just finding shards. You find shards and try to fit them together, but these shards magically have strings. Now the strings are called I forget what they're called. Doesn't matter. But basically they're cracks in the ocean that show the direction of the movement. So there's cracks that go like this from the rift, right? So the cracks that goes like this, like that. Okay. So now you can see which way these pieces went as you go back in time. So you don't even have to guess. You just have to like make them disappear and just make sure everything continues to line up, and then you'll know what hits. Where it joins. So let's say you have this vase and you just pull these strings and all these pieces come together and you have a vase. And then some guy comes along and goes like this. Opens it up like this and slaps it on a big urn. Says, no, it was like that. If the Earth was covered with granite... Oh, wait a second. I have to argue the argument about the Earth is covered with granitic rock. Are you telling me that melted granitic rock wouldn't flow outward? It would make all these broken edges? But that's physics. Oh, we don't talk to the physics. Don't talk to the geologist. Hey, physicist, come here. This is what the geologist says. The geologist says matter can't be made. Can matter be made? Well, sure. I mean, you have to define your terms. Matter can be made. You have pair production. We know E equals mc squared. Matter and energy are the same thing. Of course, matter can be made. It can be destroyed. Matter can be made. No, it can't. Yes, it can. He just said so. I'm telling you, this guy over here says so. Matter can be made. I mean, he may not think that we have a method, but essentially matter can be made. So you can't say that. No, I read in the books it says matter can't be made or destroyed. Okay. How do we get a universe?
How did this everything start? If
we had nothing and now we have all this shit. If it can't be made, then it didn't happen. So there is a mechanism that makes matter. Maybe it only happened once. 17 minutes, 14 billion years ago. I don't think so. Logically, if it keeps on moving out and we keeps on being filled with shit, doesn't it mean that it's really just kind of making more shit? Because guess what? Talk to this physicist over here. Mr. Physicist, is there such a concept as expanding? What do you mean? Does anything expand? And unless you apply another force like thermal or chemical, can anything expand like a rock? Can anything expand? No. No, there's no such concept. Wait a second, let's make it clear. Is there any such concept as expanding? Something expands. Not without applying another force. No, why are you asking me such a stupid question? Because you are saying that the universe is expanding. Well, the universe expands. Well, the forces are applied. It's getting cooler. Well, we believe. Fuck you. Excuse me. I'm sorry. Find a book. Show me where it says something can expand. It can't expand.
Tell me what we have to believe.
You tell me on one hand that there's no such thing as expanding, and the universe is expanding. I'm sorry, it just doesn't make sense.
Just decide.
Well, guess what? The universe is growing. How is it growing? Well, it's making matter. Can it make matter? Well, matter can be made, but then it gets destroyed. Well, not necessarily. You can keep it apart. How can you keep it apart? Well, you can keep it apart in a collider. You can keep it apart in a collider as long as you want. Really, really? Well, that's so what? That's not the point. Do we know everything in science yet? Do we know how matter is made? No, we don't know how matter is made. How did the universe get made? We don't exactly know yet. Excuse me, I think I know. No offense. It's just, I do my homework. Everything that I talk about has a basis in fact.
You thought about spending years and thousands of
35 years.
Well, your years.
It's pretty concentrated years.
You have just them once in life.
I actually studied a lot longer than that. Started since I was a teenager.
And even putting some really big money in this kind of study you made.
But the thing is, what I found a lot of things. First of all, I study all the sciences. I don't know anybody that does that. A science teachers in high school do that. It's one of the few people that do that. I study all the sciences. I love science. I really love science, but I study facts. I don't study theories. I actually don't like theories.
That's what I told you before. When I read everything, first reaction was they just told us this is how it happened, but no one is just thinking if it feels logic what they told us. And if you compare the two theories, just for logical reason, there is no contest.
You see, the thing is.
But then you have to study, to apply, to check. Right. I mean, whatever. Right. But if you just start checking, it's so clear that something was really insane and something it's really simple.
Right, it's very simple.
Usually the solution is always the simple one.
And that's the magical thing about it, is that the assumption that science is rocket science